Okay, so now let's solve LeetCode 1, which is known as TwoSum. So this problem is a pretty popular one, and now let's solve it. So what is the problem? So in this problem, there is an array of integers given to us. It is called nums. So nums has basically a set of values. So this is one of the combinations of values that could be present. So nums has all these values, and so you are given nums in the question, and you are given a target. Okay, so target is let's say in this case given as 9, right? So what you are required to do is, from out of all the numbers that are present, or the integers that are present in nums, you need to find, or you need to basically output the index of the two numbers such that they add up to target. So that is what we have to do here. So it is pretty straightforward in this case. You can see that 7 plus 2, this gives us 9, and then that means that the output should be an array of this 0 and 1, because 0 and 1 are the two indices of the numbers that add up to the target. The question additionally mentions that each input would have exactly one solution, and we cannot use the same element twice. And the answer could be returned in any order. So let's look at another example. What if nums were, let's say, 3, 2, and 4, okay, and the target that we were given, it was 6, then what would have been the output? The output would have been 1 and 2. Why is that? That is because when you add up 1 and 2, 2 and 4, this gives you, when you add up the index 1's value and index 2's value, which is 2 and 4, you add them up and you get 6. So that is basically the problem statement. Now the question is, how would we come up with a solution that would help us solve this problem? So for the time being, let's forget this second example and just focus on this one. So one very naive way to solve this problem would be to just iterate over every single element, right? So every single element, and then when we are iterating over this element, we search the entire the rest of the array, right, with another like iterator, and check whether if we sum these two values, this gives us the target or not. So in this case, 7 and 2 would give us the value, and then we would have got it. Let's look at a different example. What if, let's slightly modify the example. What if the value was, let's say it was 26, right? So what would have happened? The output, we, as you already know from looking at the nums array, is if we add up the values that are pointed to by indices 2 and 3, that would give us 26. So the way that this algorithm would run is that, so I is pointing to I is pointing to the first index, which is 2, and j is pointing to 7. So does do the numbers 7 and 2 add up to 26? No, it does not. Then we move on to the next value. We do the same. Is the addition of 11 and 2 giving us 26? No, it does not. Then we move on to the next one, right? And then we add 15 and 2. It is 17, not 26. So then we move on to the second value that we have. The second value is, in our case, 7. And again, we reinitialize our iterator j. It starts from the beginning, and then we just check. We check for all the values, but except when I and j are pointing to the same value, because we cannot use the same element twice, as is also mentioned in the problem description. So again, 7 and 2, they don't add up to be 26. So we move on to this value. 11 and 7 is 18. No, it does not work. What about 15 and 7? No, it's 23. It also doesn't work. So then our I moves on to the next value, which is 11. And our j pointer is again reinitialized, and then we look for the first value. Is it the same? Is it the addition of them giving us 26? No, it does not. What about 7? Is it 11 and 7 18? No, it does not. What about this one? Well, now we see that we have indeed found the answer. 11 plus 15 is in fact 26. So we return 2 and 3 as the answer. The major drawback of this approach is the time complexity, because we are using a nested loop within another loop, and both of them are iterating over the entire length of the nums array. So the time complexity is order of n squared, in which where n is the length of the array nums. The space time complexity is order of 1, and that is because we are not using any extra space. Excuse my handwriting, I'll just quickly fix this. Yeah, so complexity, yeah. So order of 1 is the space-time complexity, and this is the brute force technique. So this was approach 1, which is the brute force technique that you do. This we now have to look for something better and see if we can come up with a better solution or not. And so let's get on to that. Okay, so now we will be discussing the second approach, which is the hash map based approach, and it is more efficient in terms of time complexity. So the way that it would work is, so let's say we have the same nums array that we were discussing previously, 2, 7, 11, and 15, and our target is 26. So the first step that we would be doing is that we would iterate over each of the elements. But whenever we're iterating, what we would do is we would check if this number exists in the hash map or not. So let's say we call it nums map, right? Or nums map is the hash map that we are building. So this hash map, excuse me, yeah. So this hash map has the key and value pair. So this is the key and this is the value. So what would be the key here? In terms of the key, we would be setting it to, so for each of the values that we're iterating, we first calculate what is the value of target minus nums of I. This is what we calculate. So what does it give us? Meaning, when we are at the first index, or index 0, we are at a value 2, right? So we calculate, so this is the step 1. Step 1 is we calculate target minus nums of I. What does that give us? That gives us a value of 24. So what we do is, since 2 is not present in the nums map that we have here, so what we do is we set as key, right? As key we set this value 24, which is target minus nums, and as the value we set the index 0, which is where 2 has been found. So what's the significance of this? So the significance is that if in any point in so as the iterator moves to the other values, we do a quick lookup on the nums map, which is our hash map, and then we check if 24 is present in hash map or not. If it is present, this means that we have in previous iterations found a number such that 24's complement has been found. So the complement of 24 in order to reach the target 26 is the index 0, which contains 2. If I run through the entire array, you will understand it better. So since 2 is not present in the nums map, so what we do is we calculate target minus nums and we insert it to this nums map. Then we move on to our next element, which is 7. So what we do is we calculate target minus nums. So what value would we get if we subtract target minus nums? So that gives us a value of 26 minus 7, a value of 19. So 19 is the key here, and for the value we set the index to be 1. And what we do, let's just write it as a step 2, so it's easier for us to get it. So the key here, the key would be target minus nums of I, and the value would be the index of I. That is let me just sorry, I'll just clear it up, we'll write it in a more clearer way. Okay, now we are good. Okay, so then our iterator moves to the next value, which is 11, right? Okay, so is 11 present in the is 11 present in the nums map? No, it's not present. So what do? We calculate target minus nums, which is 26 minus 11, and then we just set we add this to the array, and this is at the index of 2. And then we move on to the last value, which is 15. Now comes the significance of this step that we're doing. Is 15 present in the nums map? Yes, it is. It is the key, right? So what does it mean? It means that since 15 is present, this actually means that we found the complement of 15 at index 2 in the nums of array. So this means that our result is the index that we are currently pointing, the I is currently pointing to, which is 3, and also where the complement of 15 was found, basically index 2. So 2 and 3 is the result that we intend to get. So if you to make it even more concrete, and even to clarify this entire step better, because it might not be very intuitive to grasp at the first glance, I will run through a different target value and show you that yes, indeed it does work. So the other target that we were working with was 9. So first I is here at index 2. We check whether 2 exists in our nums map or not. No, it does not. It does not exist. So that therefore we calculate target minus nums of I, which is 7, and 7 is set to the index of 0, which means that the complement of 7 was found at index 0. Complement meaning the number which is required with 7 in order to get the target value. And then we move on to the next step, which is 7. So is 7 present in the nums of map? Yes, it is present. See if we have found it. So this means that our result would be the current index that I is pointing to, which is 1, and the value that we got from the hash map, which is 0 and 1. And it does work because 2 and 7, we add them up, we get 9, which is the target. So this is a one pass technique to solve this entire problem with the hash map. It does not require us to do nested loops, and since it is just in the worst case we need to iterate through the entire array, that's why the time complexity of this problem is order of n, and the space complexity is also order of n, and that is because in the worst case we would have to populate the entire hash map, and then that will give us the answer. So this is how we can solve this problem with we did some sacrifice on the space complexity by using an additional data structure, which is the hash map, but we did get significantly better runtime complexity. So that was the intuition and between the two approaches, and now let's just go to the coding part. Let's now code up the solution. So I'll be showing the one pass hash map based approach that we talked about. First, we create the hash map. Let's call it nums hash. Then we will iterate over the entire nums array. The way that we'll be doing is we want the index values as well as the value of the number itself. That's why we would be using the enumerate function within the and pass nums to it in order to iterate over both the indices as well as the values. Now if the value value is not present in the nums hash, then what do? What we do then in that case, as I had mentioned, is that we assign that complement of this value. So the complement is found as target minus this value itself, and that becomes the key, and the index that on which we found the complement is set as the value. So the index is set like this way. And what could be the other case? The other case could be this value is found in the nums hash. Right, so if it is found in the hash map, in that case what we do is we simply just return the index that we are currently at, this one, as well as the nums hashes value that it is currently pointing to. So this value which the key is which value it is referring to. So that value as well as the index that we are currently at, that is what we are returning. So this is basically the entire piece of code. Now let's run it to see if it works or not. It works perfectly. If you run submit, then you'd be able to get the final answer. And so that was it, and thank you very much.